So for an introduction, the purpose of this lab was to observe the interactions and determine the amount of excess charge on charged pieces of tape. Materials, I used clear tape, roller, flat surface, and some objects for support. GlowScript was the computation. I created a computational model in GlowScript to simulate the tape and interacting forces. And for results, I had the charge on each tape was determined to be the number of electrons lost tape by each tape was. Newton's second law, a system change in momentum is proportional to the net force applied. Coulomb's law describes the force of attraction or repulsion between two electric charges, and gravitational force describes the attractive force between any two objects with mass. So there are initial conditions. You can kind of see here is a picture of what I was working with. Tape length, 0.2 meters. Tape width was 0.02 meters. Tape area was 0.004 meters squared. Atom area was 1 times 10 to the negative 10th squared. And you can see what that would look like. And the number of atoms, so you get that by doing tape area over atom area, which equals 4 times 10 to the 17th atoms. Observe model, here you go, it's a picture, my supports, it's the tape. Our system was tape B, surroundings with tape A and everything else. And the distance between these two tapes was 0.025 meters. Here you can see a diagram of what they're asking us to do. Gravitational force, that's the formula, that's the value I got. Electric force, here's the formula, value. Same for electric charge. And then electrons lost in the ratio. It can be kind of hard to read because I just had it typed out. But computational model. Here's my model from GlowScript. On the side here you can see the code. I highlighted code that I thought was particularly important, such as the charge, the E count, atom count, and the at ratio. Assumptions and errors. Assumptions: negligible force, external forces, air resistance, and friction are ignored. Point charge model: the long tape is treated as a single point charge. Uniform charge: each piece of tape is assumed to have an equal, evenly distributed charge. Some errors that could happen are charge distribution. Actual charges may be distributed unequally across the tapes. And then also charge loss. So handling or environmental factors may cause a loss of charge. What if electrons and protons had inverse charges? Constant observations, all lab observations remain identical. Interaction: charge tapes become negative, but they would still repel each other and attract the now positive pin. Why minimize the handling of the tape? Neutralization: charge tapes begin to neutralize immediately upon contact with hands or other objects. Now electron gain: the tapes attempt to gain back the electrons they lost to return to a neutral state. Alright, that's the end. Thank you for watching.